Radioactivity. This is part number 3 for the isotopes. What we're looking at real quick here, this will probably be really short, but we're looking at how do we determine if an element is stable or not. If it's unstable, then it's radioactive. That means it's going to go through this breakdown through half-lives. Well, how do we know if it doesn't do that? What we look at is we look at the ratio of neutrons to protons. So if I take how many neutrons there are and divide that by how many protons there are. So if we look at up here, I wrote on the board, we got carbon-14, which we said earlier was radioactive, and it is unstable. So I take the number of neutrons divided by the number of protons, so 8 divided by 6. Well, if I divide that out, what does that end up becoming? Well, it's going to be something like, what equals like almost 1.4, right? So that's that ratio. Because it's not 1, right, and it's greater than 1, then that tells us that that atom is unstable, right? It's going to probably start falling apart over time. Now, if we look at carbon-12, which remember I told you was the carbon that's inside of all of us. It's inside of our pencils. It's inside of plants. Right? It's all over the place. It's the common carbon that's around. He's got 6 neutrons and 6 protons. Take those two and divide them out. What do you get? 1.0. So is that stable? Yes, because it's a ratio of 1 proton to 1 neutron. So therefore it is stable. That carbon doesn't break down. That one you don't have to worry about. It's not radioactive. Now look at nitrogen that we talked about a little bit in the other video. He's got 7 protons, 7 neutrons. So we're going to take 7 neutrons divided by 7 protons. That's also 1.0. So that's also a stable form of an element, nitrogen. That's the nitrogen that's surrounding us. It's floating around in the air. And we breathe it in and breathe it out all the time. Don't do anything with it. Right? It's just there. It's 79% of the air that we breathe. But it's not radioactive, so it's not going to hurt us. Right? It is a stable form of nitrogen. So in order to figure out if something is stable, you take the nitrogen or the neutrons divided by the protons. If it's greater than 1, and the lower elements 1 through 20, then if it's 1 or less, then it's stable. If it's greater than 1 significantly, like the 1.4, then it's radioactive and it's going to decompose. Now, if we go up to the higher elements above number 20, then it's a ratio of 1.5. If you get 1.5 or less, then it's stable. If it's greater than 1.5, then it's unstable. And if you go way back to the beginning in your notebooks, one of your assignments you had to do proton, neutron, electron for elements 1 through 50. So you have all these, and you could go back, not saying you have to as an assignment, but you can go back and you can look at those numbers and see, are those all stable forms of the isotopes of each one of those elements? You're probably going to find they are for most of them, right? But know that there are isotopes for every element that's on the periodic table. All right, well, that concludes the notes concerning radioactivity. So, see you later. Have a great day.